Hello guys, this is Prime Concept. You're welcome once again to my channel. So in this video, I want to look at preparing you for your NECO 2026 practical chemistry salt analysis specifically, and we want to carry out the experiment looking at a sample of what NECO is likely to bring on your exam day. So I've been able to draft a sample of how the question would look on that day. So I would advise you to use this video and practice because I predict that the question will come in this similar way on your exam day. So I'm going to be showing you how to perform the experiment live and then how to write your report. I'll give you the report that you will be using on the day of your exam and it will guide you. So remember, we have videos on this channel for practical chemistry. We have also done titration experiments in this particular channel or on this particular channel. So do well to check our other videos, both practical physics for electricity, for your rectangular prism and your mathematics. So do well to check. If you are yet to subscribe, don't forget to hit the subscribe button. You'll be getting a lot of wonderful concepts from our channel. And again, as I'm wishing every one of you to cross over to the university, I want to also use this opportunity to remind you that on this channel, we handle all your first year science courses for Chem 101, Maths 101, Physics 101, and so on. So it means if you are getting into the university, one of the things you want to do for yourself now is to make sure you are subscribed. When you get to university, you'll be seeing the value of this channel because you'll be doing a lot of things in first year that might be confusing, which I've been able to break down on this channel. So very quickly, not to waste more time, we are going to run through the instructions and then begin to carry out the experiment very fast. I won't waste time. So they said C is a sample of a salt, right? So C is an unknown salt for your exam. But at the end, you'll be able to see that we can deduce what the salt would be from the experiment. Carry out the following test on C. Record all your observations and inference. So the first part of what you're going to do is to put a small quantity of C in a test tube and add about 5 cm cube of distilled water. Shake thoroughly. So I'm going to read through it, then we'll start performing this experiment. Now, B part of it, they said to the first portion, add dilute sodium hydroxide solution dropwise, and then in excess, you observe what happens. Then warm it again, warm the mixture gently and observe what happens again. Record your observation and then the inference or deduction from that. The third part of it, they said to the second portion, add, remember, what is actually happening here is that when you put a small quantity of C in a test tube, and you add distilled water, you're going to share it into 3 different portions because you have to the first portion, to the second portion, to the third portion. So you're going to share into 3 different test tubes and begin to carry out your experiment. So to the second portion, add dilute ammonia solution dropwise and then in excess. So you record the observation and your inference. So they said to the third portion, add barium chloride solution followed by dilute hydrochloric acid, record the observations and inference. So they said from your observation in B, C, and D, state the cation present, we're going to do that. State the anion present, we're going to do that. So very quickly, let's start. So I've been able to dissolve my salt, so with distilled water. So upon dissolving my salt in distilled water, this is what I got. So you notice that the salt is soluble. It formed a blue solution, clear solution. So there's no part of it remaining. So the salt is a soluble what? Salt. That is the first observation. And when you dissolve that salt in water, it dissolves to form a blue solution. That is the first observation you have made. And you tell them in your inference that copper is likely to be what? Present. Is likely to be present because it is usually copper that would give us blue solution, right? Yes, that is the first line. Test is sample C plus distilled water. What is your observation? Your observation is what? Sample C is soluble. Sample C forms what? A blue solution. What is your inference? Copper likely to be what? Present. So I'm going to give you the report anyway. So now very quickly, I want to put in a test tube a small portion, a small sample. So this is what I have in a test tube, right? Now let's look at the first part. They say to the first portion, add dilute sodium hydroxide solution dropwise and then in excess. So where's my sodium hydroxide? So this is my sodium hydroxide. So this is my sodium hydroxide. So I'm going to add dropwise, just a little. So what did you observe? Now you would notice a blue gelatinous what? Precipitate formed. That is the observation. Blue gelatinous precipitate formed. You can see it. Blue gelatinous. You can see that thickness of that blue. The thickness, it looks as if it's clotted. So that is what you call blue gelatinous precipitate. So let's see what happens in excess. So in excess, did you notice anything? Yes, the gelatinous precipitate remains. So it means that the sample is insoluble in excess sodium hydroxide. So it still remains what? Insoluble. That is the observation. Sample remained insoluble, right? So let us see. They now say we should warm it. So what it already means from your inference is that copper is present, right? Copper is what? Present. Now let us heat and see what happens, the outcome. I'm going to use my lighter to heat. Let's see. Let's just give it some time of heat because I'm using a low heating source. What are you noticing? It is very obvious already. It's turning black. It's turning black. It's turning black. That PPT is turning black. And if I keep heating this over a long time, you notice eventually that everything becomes what? Black. Yes, yes. Can you see it? It's beautiful. It's beautiful to do experiments and see clear observations. Yes, I think I'll stop. And what did you notice? It gradually started turning black. So what you're actually seeing, if I were to give you the equation of reaction, what has actually formed here is that the copper, because this is sample C, is actually copper sulphate, right? Even though on the exam day you're not meant to know, it's actually copper sulphate. So what has happened is that your copper hydroxide, remember when you added sodium hydroxide to this solution, you formed a blue gelatinous PPT, right? And that blue gelatinous PPT you formed is actually copper hydroxide. So when you started applying heat, that copper hydroxide is breaking down to give you what? Copper oxide, which is black. So copper oxide is actually what you're seeing forming, which is actually what? Black. So when your observation is that precipitate turned black upon what? Heating, then what is your inference? Copper 2 ion confirmed. So this is one of the ways you can confirm copper. So your inference is that copper 2 ion is confirmed. So you have confirmed copper 2 ion. So we're going to see what step C is going to be. Let me discard this very quickly. So now, the next part, they said to the second portion, add dilute solution of ammonia. So let's create a second portion. So we have the second portion. Okay, let me increase it. So we have the second portion, can you see? Which is still our blue solution, clear solution. You can see it's blue, clear solution. So now, they said to the second portion, add dilute ammonia solution dropwise. So let's get our ammonia. Remember, ammonia has a pungent smell. So once I open it, it's not always good to inhale it too much. It's already smelling, pungent smell. So this is my ammonia. I'm going to add dropwise. I'm going to add dropwise and then in excess. Dropwise. I mistakenly added too much. But assuming we added dropwise, you would first notice light blue. And then upon excess, you will notice that it has become what? Deep blue, and it is soluble. So that's the sample dissolves in excess ammonia to form what? A deep blue solution. Let me add more. So sample dissolves to form what? A deep blue solution. And this deep blue solution you're actually seeing is actually what you call tetraamine copper 2 complex ion. So this is what you actually have formed. This is a complex ion, tetraamine copper 2 complex ion. So that is what is actually formed. So what is your observation? Your observation is that light blue, when you added ammonia in drop wise, it formed a light blue solution. And when you added ammonia in excess, the solution became what? Deep blue. Of course, the sample was soluble. It gave a deep blue solution, right? Yes, in excess. So that is for the third step. Now let's look at the fourth step. Let me discard this very quickly. So, all right. Now, then they said to the third portion, add barium chloride solution followed by dilute hydrochloric acid. So let's see to the third portion. So I'm going to create the third portion now. So this is my third portion. To this third portion, I'm required to add barium chloride solution. Barium chloride solution. So where's my barium chloride? All right, I have my barium chloride. I actually made a solution of this. I got the solid salt and made a solution of that. Now this is my barium chloride. I want to add it. Let's see. Remember, this is your blue solution of copper of the sample C, right? So let's add barium chloride. Wow, can you see this? It is very obvious, even to a market woman, that you have formed what? When you added barium chloride solution, what are you seeing? You're seeing a white precipitate formed. White precipitate formed. So what we're actually testing at this stage is actually the what? The anion. Remember, I didn't mention, of course, in step B and step C, we are testing for the cation. So step C, when you add ammonia solution in excess and you get a deep blue solution, what is of sample C, it means that copper is actually what? Present. So that is a confirmatory test for copper. So copper is what? Present, no longer likely present. I'll give you the report procedure and you're going to record it. So then in our step D, when we added barium chloride, we formed white precipitate. Now white precipitate can indicate the presence of some anions, which would include, if we have, whenever you add barium chloride to a sample and you get white precipitate, it could indicate that sulphate ion is there. It could indicate that sulphite is there. It could indicate that sulfide ion is there. It could also indicate carbonate ion. So any of these ions could be present, and that is why they said we should add dilute hydrochloric acid to this. Now let me tell you, if you add dilute hydrochloric acid to this and it becomes a clear solution, this white precipitate disappears. So it means that sulfide and carbonates are not there. May likely be there. Are you getting me? If you add hydrochloric acid and this thing becomes, the white precipitate disappears, it means that sulfide, and carbonate may likely be there. You may need another test to carry out and know which of them is there. But when you add that dilute hydrochloric acid and the white precipitate remains, it means that sulfate is actually what? Confirmed. Sulfate is actually what? Confirmed. So let us add dilute hydrochloric acid and see what happens. Let's see. dilute hydrochloric acid. Okay, so let's see. So what did you notice? The white precipitate still remained. It looked as if the white precipitate has gone down. Why? Because I left it for some time when I was explaining. So, but you still notice that the white precipitate is still there. It's still there. It didn't disappear. So it means that sulfate ion has been what? Confirmed. So at the end of the day, what are the ions? Let's answer the last part from our experiment. Then from your observations in B, C, and D, state the cation. The cation that is present is copper 2 ion. The anion that is present is what? The anion is sulfate ion. So when these two things combine, the salt that is likely there is copper sulfate. It could be hydrated, it could be anhydrous. So copper what? Sulfate. So this is the salt that you actually have in your sample C. So very quickly, I'm going to show you the report procedure that you're going to follow on your exam day. So if you have watched me up to this point, this last part is something that you really need to get. So don't go without subscribing, and you need to see the report procedure. Do well to like this video, comment, share with your friends. Remember, this exam is in 2 days' time, so you can't afford not to be very much prepared. On this same channel, I have done titration. So go back and check, learn the table of values, observe the calculations so that you can be prepared. So let me do the reports. All right, so this is your table. So just follow this, and then this is how you're going to record from the experiments we have done. I just decided to do it this way so that you would follow this exact step and make your recordings. All right, so you can see the first one, sample plus C, sample C plus distilled water. You see the observation, blue crystal dissolves completely to give a blue solution. What is the inference? Sample C is a soluble salt. Copper may likely be present. So the B part of it, first portion of sample C plus sodium hydroxide dropwise, then in excess, and mixture plus it. So you'd see the observation and so on. So this is what you're going to follow, and I'm wishing you great success on your exam day. Don't forget to like this video, comment, and then subscribe if you're here to subscribe. Also share with your friends. Tell them Prime Concept is doing wonders in your practical chemistry, physics, and even your mathematics. Thanks for watching Prime Concept.